Elon Musk has several times complained of what he refers to as production hell, something the rest of the world just calls manufacturing. Tesla Motors has enjoyed an almost baffling brand loyalty from the onset. Baffling because its production processes involve a whole lot of work. Many hitches have arisen in their quest to transition the automobile industry from reliance on fossil fuels to an electric base. Not least of these hitches was Tesla failing to automate the new vehicle assembly line for the Model S at the Gigafactory in Vermont. How did Tesla go from a threatening failure like that to churning out the majority of the world's supply in electric vehicles in such a few short years? Stay with us until the end of this video to find out, and don't forget to like this video and subscribe to our channel for more exciting videos. When Tesla reported its second quarter earnings in 2016, Elon Musk had to answer to analysis, and in those answers he revealed just how much pain production had caused the company. While Elon Musk was no longer keeping vigils over the production state, he claimed to still have had a whole lot of mental scar tissue from earlier this year. He had come up with a solution for the issues that they had faced, such as outfitting the factory to run on machine speed instead of being dependent on people. He put it this way: you can't have people in the production line itself, otherwise you'll drop to people speed. So there will be no people in the production process itself. This didn't mean that the factory floor will be completely free of humans, however. He also said that people will maintain the machines, upgrade them, and deal with anomalies. Unlike other companies, Tesla did not go the usual route of replacing the factory floor staff with machines. The robots, while wonderful additions, will need to be looked after, as only the human brain can actively solve problems. Musk wanted to take out the manufacturing speed being entirely dependent on humans, and so he limited them severely. The Model 3 was said to be mass-delivered in 2017, so this automation was supposed to be the plan that would bring production speed up to speed. It would cost a lot for Tesla to take the former General Motors and Toyota factories that were producing less than 10,000 vehicles per year and turn them into something capable of complete automation. Elon Musk was ready for the investments. Unfortunately, the work-in-progress factory had some hiccups when the new automated process was applied to the production of the Model S. However, Elon Musk's mind pushed him to think up something big, something innovative. He raised a tent on the factory site and housed almost a third of the assembly line in it. By 2019, Tesla delivered 250,000 cars, and then almost doubled that supply in 2020. This delivery rate was a sure sign of Tesla's growth. They had come a long way from being the butt of many harsh criticisms. At maximum capacity, the Gigafactory in Vermont can now manufacture as many as 5,000 vehicles a week. What did the record-breaking production line look like? It was straightforward. The major production line concentrated on installing the already manufactured parts into the car's frame. For example, the case at the final stage of production would be one of a whole seat being fit instead of watching the frame be set up and the material being stitched. There are actual videos of the entire dashboard being fitted into their vehicles, complete with the infotainment devices. Tesla has cut its production line to a basic 43 steps. And this might seem like a lot. It falls between a quarter and a third of the regular amount of steps used by other manufacturers. The factory, specifically the Model 3 warehouse, has over 1,000 robot employees at the moment. One observed advantage of this workforce is that there is a lot of time saved on each vehicle, while accuracy is not overlooked. One problem that critics had with early Tesla deliveries was the panel gaps. These gaps had been tremendously enhanced, so much so that Tesla's manufacturing quality is being compared to that of the Germans. Anyone who knows cars will know how much of a huge compliment that is. In addition to this, there is a cleaner car frame sent to the metal workstation. The robots make sure that there are fewer imperfections to take care of before the car is painted. Of course, this also helps to bump the vehicle's quality even further. The speed achieved in production by these machines is simply astounding. It only takes the automated machinery 90 minutes to move the car from its bare shell form to a deliverable vehicle. At that time, a production line spanning about 1,000 feet, and we can already see a few reasons for Tesla's boom in supply. Musk's goal for its manufacturing process is to be able to deliver about 1 million cars per year. After seeing a 36% increase from 2019's numbers in the abnormal year that was 2020, this has a high possibility of being Tesla's reality this year. The best way to get this mission to take shape is with the establishment of Tesla's various factories around the world. A global spread of manufacturing would do so much more than depending on the capacities of a tent in California, no matter how capable its robots are. Reports have suggested that there may just be a Gigafactory in every continent that has people across the world working. That might not take too long to manifest. In less than a year, Tesla turned an empty plot in Shanghai, China into an operational Gigafactory. The related factory in Berlin might eclipse that one, with it expected to be pumping out Model 3s and others this year. These new facilities, commencing with the company's Nevada Gigafactory and then extending to the much more efficient plant in Shanghai, with new factories slated for Berlin and Austin, Texas, are going to be decked out from the onset for what we might call the Tesla production system. The automation system set up in Vermont will no longer be one of a kind. Roughly, the output studies suggest that each new factory could assemble 250,000 vehicles a year, which could very well give Tesla its production goal of more than 1 million units. While that might not be a lot in the grand scheme of automobile delivery, especially when compared to 8 million vehicles GM made and sold in the last year, it would still be a feat for a company that is not as diversified as some of the other legends in the game. It has remained directed on battery power, and it keeps dominating a global EV market that just barely began growing. Its competitors in the EV market are lagging far behind. Tesla's production ways are unconventional, to say the least. The relatively young company refuses to structure its ideas after the automobile giants have. Outsourcing stages of vehicle production is nothing new or shameful in the industry, but Tesla does not subscribe to it. Something as intricate as stamping, which is bending the vehicle's metal panels into shape, is done in-house. Tesla plans to cut down costs everywhere possible, and the company does love manufacturing, so it's not a burden. Musk often talks about how we, Tesla, bring a massive amount of effort into manufacturing engineering, the machine that makes the machine. He's begun talking about the machine that makes the machine since the early days of the Model 3's production. "We're getting way better at making cars," he said in an interview. You can see that in Shanghai. You'll be able to see that even more with Berlin. And we're really changing the design of the Model 3 in order to make it more manufacturable. "We love manufacturing," he added. "It's awesome. And I really think more smart people should be working on manufacturing. Automated manufacturing is not a complete walk in the park. Some machine errors have to be corrected by totally redoing a step in production. There are errors caught by a human after a machine has moved the car to the next station." Initially, the final assembly area saw the company using robotic arms to put in Model 3 seats. Unfortunately, the robot in charge was sluggish and unstable in attaching the necessary bolts to secure the seats. Connecting the wiring that provides the seats with power was also an issue. However, the company officials said that workstation was altered so that the robot moves the seats into place and workers deal with bolts and the fitting of fragile electronic connectors. Lars Morave, the company's director of chassis development, related another story of near-machine failure. The New York Times reported this story of how, for months, Tesla engineers struggled to get a robot to guide a bolt through a hole accurately to secure a part of the rear brake. They found a maddeningly simple solution. Instead of using a bolt with a flat tip on a threaded end, engineers switched to a bolt with a tapered point, known as a lead-in, that can be guided through the hole even if the robot is a millimeter off dead center. Tesla did a lot of experimentation to get its production process right, and they still have a ways to go. The entire process is based a lot on artificial intelligence and machine learning, which eases the correction of errors and makes room for steady development. Tesla has a system in place to receive massive feedback about its cars and its users, but it still works with the feedback from its assembly machines. This allows them to review and make engineering changes as often as necessary. Tesla's growth in production would definitely include advances in computer vision, how a computer sees and reacts to its environment. The production line would come to depend heavily on this vision. The cost of this improvement will be a high cost in the beginning, but in the long run, it would end up paying off and reducing the cost per car. The autonomous machines are not just successful in Musk's reports. There have been several videos and tours taken in the Gigafactory. Some even report that if all goes right, and the right modifications are made, the factories could double their current weekly output. 10,000 cars a week from each factory is nothing to scoff at. Musk truly is to set his company as the standard, not just in electric vehicle specifications, but also in the manufacturing process. He spent the years of Tesla's obscurity learning to perfect this system that will soon enough be copied by other companies. With all this progress Tesla has made, the idea that people would wait months to receive their vehicles makes more sense. True production takes about 3 to 5 days, but most of the delays are in shipping and in the backlog of the orders. It makes one start to wonder if companies can start to truly take the world to Apple's campus is now known as one of the most record-breaking campuses and tech headquarters in the world. This structure looks like a giant spaceship parked somewhere in Cupertino, California, and has elicited a lot of speculation as to what actually goes on there. The Apple Park takes up about 176 acres of land, and although the park looks very modern, it is the brainchild of founder Steve Jobs. Far from being just an office structure, the park combines many jaw-dropping features that make it easily the most impressive headquarters in the world. It is also certainly the most expensive by far. What exactly is the spaceship that costs so much to construct? Watch this video till the end and find out, and also you're not going to want to forget to subscribe if you've not done that already. The Apple Park has been planned since 2006 when it was first announced by Steve Jobs. It takes a lot more of a modern approach to design than Apple's other campus, One Infinite Loop. The older campus, where Apple has resided since 1993, is laid out to look a lot more like a university campus, but this new park is something totally different. When Steve Jobs and Apple designer chief John Ive began work on the design for Apple Park in 2006, it was actually initially called Campus 2. The architectural details were submitted to the Cupertino City Council in 2011, and demolition of the land began in late 2013. I've worked intimately with the design firm Foster & Partners on this massive undertaking. His design influences are seen throughout the campus, and he had this to say about the process. As a design team, our goal has been, in some ways, to get design out of the way, I've said. We tried to define a solution that seems so inevitable that it does recede. He stated this, referring to the philosophy that is behind everything Apple designs. Even the stairs received such scrutiny. There are so many connections between floors, he continued. There are light wells that go all the way down. You have visual connections to the floors and connections by the stairs. The official groundbreaking was originally scheduled to start in 2013 to allow the building to open in 2015, but delays meant that construction didn't actually start until 2014. Apple Park officially opened for business in April 2017, and teams continued to move into the facility throughout the rest of the year. In the initial estimates, the building was supposed to cost just about $500 million. Plans changed when the land alone set Apple back $160 million, and eventually the budget skyrocketed to about $3 billion. By the time the facility was actually ready for use, about $5 billion had already gone onto the campus construction. With Apple, it is not as large of a cost as it may seem. After all, the company's worth about $2 trillion and is still growing rapidly as it nets in profits in tens of millions of dollars yearly. Let's get into this impressive facility. The main ring is an architectural miracle. The one circular building houses most employees. It is 4 stories above the ground and 3 stories underground, and has a workspace for over 12,000 staff with over 1.2 million square feet of office space. About 83,000 square feet of the ring space is for meetings and breakout spaces in the building. The building uses only glass for its walls and views of the inner courtyard as well as of the exterior landscape facing the exterior of the building. It features the world's largest curved glass wall in its interior. There are about 100 large glass panes that are 45 feet tall on the building's exterior, and about 3,000 smaller ones inside. With low-energy LED lights, the sun's rays, and all that glass, the spaceship is one incredibly lit building. This structure is Apple's largest attempt to embrace sustainable energy, as the whole building is roofed by solar panels, one of the world's largest rooftop solar farms. These panels generate enough energy to power 75% of the entire campus at peak work periods, which is about 17 megawatts of power. On-site fuel cells, powered by biofuels or natural gas, power the rest of the campus. The main building also breathes by making use of a natural ventilation system. There are no traditional heating or cooling systems for about 9 months every year, and this further reduces the facility's environmental footprint. All interior wood used for furniture in the building was harvested from a certain species of maple, and Apple worked with construction companies from about 19 countries for designs and materials. The design conceals the road and parking spaces underground. The inner part of the circular building contains a 30-acre park featuring a pond with fruit trees and winding pathways inspired by California fruit orchards. This shows that about 80% of the facility is still green. This was a deliberate decision made by Jobs and the architects. The landscape architects planted about 9,000 drought-resistant trees, including apricots and some varieties of apple trees. The central area also features a beautifully designed artificial pond. The grounds show off 3.2 kilometers of walking and running trails to encourage the workers to have a healthier lifestyle and not stay stuck behind a screen. It also stocks up on 1,000 bicycles to get from one facility to another. There is also a 2-story yoga facility to help the employees loosen out tense muscles. Another impressive part of the campus is the auditorium, formerly known as the Steve Jobs Theater. After the co-founder and former CEO of Apple, the facility is located atop a hill on the campus. It is an underground, 1,000-seat auditorium that is intended for Apple product launches and press meets. It has a large above-ground cylinder-shaped lobby with stairs down to the auditorium. The theater is linked to 350 parking spaces on North Tantau Avenue and a pedestrian path leading to the main campus located northwest of the theater. The theater's lobby has cylindrical-shaped glass walls and absolutely no support columns, which give an unhindered 360-degree view of the campus and its surrounding area. The campus also boasts 7 cafes, with the largest one being a 3-level cafe for 3,000 sitting people. This cafe has a light-colored stone lining and glass railing with no metal support, and is surrounded by extensive landscaping. The mezzanine space of 20,000 square feet can accommodate 600 people and 1,750 seats on terraces outside, with a capacity to serve 15,000 lunches a day. That is housed by specially designed 500 tables made of solid spessart, white oak, measuring 18 feet long and 4 feet wide. The sports tables and benches resemble those in Apple stores. Every little detail of the campus was thought through. There is a 100,000 square foot fitness center that is located northwest of the campus. Apart from gym equipment, the fitness center features other amenities like changing rooms, showers, laundry services, and rooms for fitness group sessions. The research and development facilities feature 2 large 300,000 square feet buildings on the southern edge of the campus and are occupied by more than 2,000 people. The top floor of each building houses a department comprising industrial design and human interface teams, formerly headed by design chief Johnny Ive. More recently, Apple started launching care clinics in Santa Clara County to provide accessible healthcare and promote healthy behaviors right in the company's workplace. The concept of bringing healthcare into the community emphasizes the element of inclusiveness and incorporates actual change to the traditional healthcare options in most firms. Apple Park Visitor Center is a 2-story, 20,135 square foot structure with 4 main areas: an Apple store featuring Apple-branded merchandise, t-shirts, hats, tote bags, postcards, not sold at regular Apple stores, a 2,386 square foot cafe, an exhibition space which currently showcases the 3D model of Apple Park with augmented reality, and a roof terrace overlooking the campus. It opened to the public on November 17, 2017. The estimated cost of the center is $80 million. The property is across the road from the campus proper and is a Santa Clara residential neighborhood. The underground parking garage, with close to 700 spaces, has an estimated cost of $26 million. The visitor center is the only part of Apple Park tourists are permitted to visit. There is also the Glendinning Barn on the grounds. The barn is a historical landmark, moved and restored by Apple during Apple Park's construction. It was originally part of the farmyard that housed apricot, prune, and cherry orchards. The barn is now used for simple storage of groundkeeping tools, but also stands as a symbol of community and development at Apple Park. Transportation to and within the facility is fairly easy and seamless. Employees and visitors traveling by bus will board and depart from the bus station, which leads to the main campus via 2 wide staircases. The area is also served by the Santa Clara Valley Transportation Authority, VTA, which runs a local bus service from Cupertino to nearby cities. Prominent transit consultant Jarrett Walker, who worked on the VTA on providing services to the campus, criticized the campus design due to its poor access to the public transport system, which is one of the main criticisms of the campus. Parking in the facility is located both underground and in 2 large parking structures, accommodating approximately 14,200 employees. Cupertino regulations required a minimum of 11,000 parking spaces, 700 of which have electric vehicle charging stations. There are 2,000 parking spaces in the subterranean parking garage. The parking is supervised by sensors and apps, which manage the traffic and parking spaces. There are an added 2,000 bicycle parking spaces in the subsurface car parking garage. No matter how much they had to deal with, Apple Park is an impressive piece of architecture. However, was it worth the resources? Let us know what you think. When Elon Musk's SpaceX got into the business of rocket making, It promised reusability, lower launch costs, and easier access to space. Over the last few years, the company has taken steps to make good on that promise, thanks in large part to the success of its Falcon 9. Through a lot of determination and consistency in using new technologies, SpaceX has been able to land rockets back on Earth. This has made space travel more popular, as the claims made by SpaceX to move people to Mars may actually become a reality in the near future. Landing rockets after being launched into space seemed like an impossible thing to do, but SpaceX did the impossible, as now they have a track record of landing rockets with accuracy. In this video, we'll be looking at how SpaceX is able to land these rockets with remarkable accuracy. Watch this video until the end, and don't forget to subscribe and like the video if you haven't done so already. For the past decade, the world has marveled at how much SpaceX has revolutionized rocket technology and space travel. Their ambitious plan of launching a space car into orbit and colonizing Mars have garnered a lot of attention never seen before. The wide coverage it has gotten is the largest so far, and is only similar to NASA's Apollo program about 40 years ago. The core of their amazing pursuits is one of the greatest developments in the history of rocket engineering, which is being able to reuse rockets. The SpaceX Reusable Launch System development program was first announced in 2011, and was set to create reusable rockets that would largely reduce the cost of launching rockets. It is a privately funded program that's designed to develop a set of new technologies for an orbital aircraft. SpaceX has been developing the technologies over several years to facilitate the full and rapid reusability of space launch vehicles. In order for them to achieve this, SpaceX decided to undertake the recovery of rockets using power descent. Their plan was to be able to launch a rocket vertically into orbit and then return it to Earth in a controlled descent and vertical landing and specific landing site, either on land or on the seas. In the past few years, SpaceX has not only been able to create a reusable rocket, but has proven that it is reliable and economical to use the relaunch system. So, how exactly are they able to get their 70-meter-long rockets with a mass of about 500 kilograms to land vertically on the ground? This happens based on two particular things: experience and perfectly engineered rockets. We're going to be taking a look at the history of the Reusable Launch System development program. The program was launched in 2011 and did not successfully land any Falcon 9 boosters until 2015. It took about 2 years after this to have a good landing rate for successive launches. They spent 5 years experimenting with their landings and testing technologies, as they learned to develop new rockets. The first try was a vertical takeoff and landing with a rocket known as the Grasshopper. This vehicle completed 8 successful flights, from 2012 to 2013. Given that there was some success with the Grasshopper, they went on to equip the Falcon 9 boosters for power descent and tested its landing from 2013 to 2015. The first tests were initially just to be able to land between the first 10 kilometers. However, with subsequent tests, there was an improvement. Much later in the year 2015, there were tests on an autonomous drone ship which ended in failures when 4 consecutive barge landings failed dramatically. In spite of the failures they encountered, they used the experience, they used the data they got from these to redesign and redeploy for a better vehicle. More Falcon 9 landing tests were performed in 2015 and 2016, both on drone ships and on land. By early 2017, the successful landings started to become a normal occurrence as the SpaceX team had gotten the hang of it. From that time, landing tests ceased being referred to as experimental. Up until early 2018, SpaceX was able to boast of 100% landing accuracy for up to 10 meters. The improvement in the accuracy from 2013 to 2018 was phenomenal, showcasing almost a change of 1,000 times. Now it's time to shift our focus from the experience to the actual building of the perfectly engineered rocket. Whenever the Falcon 9 is launched, the rocket separates into 2 stages in the upper atmosphere. The payload is carried into space by the second stage, while the first stage returns to Earth at a landing site for reuse. The booster is pre-controlled to go through a specified flight path and must also perform a series of controlled maneuvers so that the path can be maintained and the vehicle would land vertically on the landing pad. The particular flight path is dependent on whether or not the rocket lands on a floating drone ship on the ocean or on land. Landing at sea makes the landing a bit more complex, as the ship would have to be located with precision as the rocket tries to touch down. The toughest engineering challenge encountered by SpaceX is the development and research to build a rocket capable of understanding all the controls and maneuvers. This movement includes those movements necessary for a controlled landing. Immediately, both stages are separated, and the first stage recalibrates itself and moves back in the direction of the Earth, so that the best trajectory towards the Earth is obtained. As the stage descends, the booster goes through a re-entry burn as it gets closer to the Earth. This is done to reduce velocity as it comes closer to the ground. As the booster is almost at the landing site, another reorientation takes place so that it is confirmed that it is in line with the landing pad. A landing burn then occurs to bring its velocity to zero as it touches down on the landing pad. Throughout the whole flight, from the separation of stages to the landing, the orientational velocity is continually measured and the trajectory is adjusted constantly to ensure that the correct flight path is maintained. For SpaceX to properly achieve this, several rocket technologies have been worked on, all having been examined through the expertise of the SpaceX team. Some of these technologies are pivotal to the reusability of these highly sophisticated vehicles. Number 1. Thrust factor control. The Merlin engines were the engines using hydraulic actuators which were there to adjust the thrust as needed. There had to be a way to vary the thrust factor while changing orientation both in the Earth's atmosphere and in space. In space, aerodynamic control surfaces such as fins don't have any effect. Thrust factoring is normally used for rockets as well as military equipment like missiles, but it could only be used when absolutely necessary when the Falcon 9 needs to be able to maneuver easily. Number 2. Cold gas thrusters. 8 nitrogen cold gas tanks are mounted on top of the Falcon 9's first stage. One pod is on each side of the rocket, having 4 thrusters each. The cold gas thrusters are vital for the orientational control in the rocket. They are particularly useful for the flip maneuver of the rocket after the first stage is separated from the second. This is due to the large lever arm of the rocket between the rocket and the center of mass. It's also used to control the rocket at times during the flight when the gimbal and main engines are no longer working. Number 3. Reignitable engines. Given that the first stage has to perform burns 3 different times, the main rocket engines require reignitable engines. Thus, the first stage booster is designed in such a way that it can reignite at supersonic speeds, as well as in the lower atmosphere at transonic speeds. Number 4. Inertial navigation and global positioning system. The Falcon 9 uses several types of positioning and navigational systems, each with different types of sensors used to dictate the position or orientation and velocity of the rocket. The global positioning system is also important for geolocation. The computer on board gets data in real time from the INS and the GPS and continually checks if it's according to the pre-designed flight path. Whenever there's any deviations detected, the rocket can be adjusted as required. Number 5. Deployable landing gear. For vertical landings to be possible, the Falcon 9 has 4 lightweight landing legs which are used with high-pressure helium just before they land. Each leg is made up of carbon fiber and aluminium. An added feature is the impact attenuator, which is necessary for hard landings. The total span of the deployed landing gear is about 18 meters, while the entire landing system does not weigh more than 2,100 kilograms. Number 6. Deployable grid fins. 4 titanium grid fins are mounted at the top of the first stage booster. They're usually deployed when the rocket is returning back to the Earth's lower atmosphere. The fins are aerodynamic control surfaces used for precise control of the orientation of the rockets right before landing. Just those 4 grid fins are primarily responsible for the 10-meter landing accuracy of the Falcon 9 first stage booster. They were first used in the 5th attempt of the reusable launch program in 2015. Iterations of the design continued through 2017, and this is what has given SpaceX the landing accuracy that it has today. SpaceX successfully employs years of experience and useful rocket technologies to accurately land rockets, and they have gotten a lot more in store for us. We will simply wait until we can finally get that summer trip to Mars. As of 2020, SpaceX is actively developing the Starship system with the intent to make it a fully reusable 2-stage launch vehicle, intended to replace all of its existing launch vehicles and spacecraft used for satellite delivery and human transport, Falcon 9, Falcon Heavy, and Dragon, and also eventually support flights to the Moon and Mars. In addition, it could also be used for point-to-point transportation on Earth. Kindly tell us your comments about SpaceX methods down below. Do they have much more to offer? Will Elon Musk have to give up on his dreams? Most definitely not. We would have to wait and see what he has up his sleeve. Thanks for watching this video. While you're here, go ahead and click on one of these two videos on your screen. See you there.